Alright, ladies and gentlemen, this is another episode of Horrible Teaching. Today we're going to talk about expressions. It is currently about 9 o'clock at night. I'm watching the Seattle Seahawks play the Buffalo Bills. It is tie game 7-7. It's only 4 minutes into the game. The Buffalo Bills have the ball, but they're not doing much. We're going to go ahead and get started with today's lesson. Today we're going to talk about expressions. Your goal for the day is, as a student, you should be able to write algebraic expressions using addition, subtraction, multiplication, and division. Now, just to let you know, what are expressions is a question that we need to answer. Okay, that is something that you'll need to know at the end of this video. We're going to go ahead and get started right now. Just to let you know, you need this graphic organizer. This is in graphic organizer number 1 if you are not somebody that already has it. So you'll need to go and get this one out of graphic organizer number 1. Remember, you should be able to write algebraic expressions using addition, subtraction, multiplication, and division. We're going to get started. Okay, this does not go in the first box on your graphic organizer. This is just some information, but it is super important, and you will be asked this several times. Okay, an expression is not an equation because it does not have an equal sign. Okay, there are also two types of expressions, but the key thing here is an expression does not have an equal sign. An equation has an equal sign, and those are two totally different things. In fact, you've been solving expressions every time you've done the order of operations, because there's not an equal sign. Okay? So here we go. This is an expression, 5 plus 84. Notice there is no equal sign. This is also what we call a numerical expression. That is because this numerical expression is made up of two numbers and a symbol. This symbol is also known as an operation. Okay, so anytime it says a symbol, we're basically talking about an operation. In this particular case, it's adding. So we have 5 plus 84. Notice those are both numbers. Okay, and it's separated by a symbol or an operation. That's a numerical expression. We'll talk more about those in just a second to put down in your notes. Here's another example. We have 3x plus t. The difference between this one is very simple. We have 3 and 10. Those are both numbers. We have our operation or symbol, which is the plus sign, but the major difference is this x, okay? And this x does not represent multiplication. So I want you to understand that we do not want to use x's anymore to represent multiplication, okay, in anything. So from now on, if you see multiplication, you need to see things like this. 3 times 4. Okay, that's one way you can write it. You may also write 3 times 4, and the only other way that I will allow you to write this from now on, because we're talking about algebra and now we're going to talk about variables and x is a variable, is maybe 3 and using a star to represent multiplication. But these two are the most common. These are mathematical. Let's try to use those, okay? So here we go. That's an algebraic expression. Once again, it's an algebraic expression because it has numbers, it has an operation, and it has a variable. We're going to go ahead and get started. Okay? Notice, once again, in both of theirs, there is no equal sign. That is because they are expressions, they are not equations. That's important because today we're talking about expressions. So when you write down expressions, you need to make sure that there's no equal sign. Moving on. So a numerical expression. This one is what you need in the first box of your graphic organizer. What is it? A numerical expression is just simply something that only contains only numbers and symbols and no letters. Okay, you need to go ahead and copy that down. A numerical expression contains only numbers and symbols and no letters. Here is an example. 5 times 3 plus 8. Okay, which would look like this. Let's go back. And any of the other ones could be such as, let's say, 3 plus 8, or 2 plus 4, or 2 divided by 1, minus 8. All of those things are numerical expressions because they only include numbers, operations. That is it. Okay, let's move on. Next one, algebraic expressions. Algebraic expressions contain only numbers, symbols, and variables. This is a little bit different. Okay, it is also sometimes referred to as a variable expression. You don't need to write that part down. The major part that you need, okay, is from here to here. You guys need this part, okay? An algebraic expression contains numbers, symbols, and variables. So the big difference is it contains variables. That's what makes it an algebraic expression. We're going to show you some examples. You need to write this one down on your graphic organizer. The product of 3 and x. And if you look right down here, you'll see that we have 3x. 3x. What that means is multiplication is our symbol. X happens to be our variable. Okay, you need to know that this is a variable. All right, and 3 is our number. So we have 3 things. We're going to do multiplication. We know that because they're right next to each other, and that's what it means. Okay, we have a number, right? And we have a variable. That makes it an algebraic expression. Here's another example. The sum of m and 8, which is just simply m plus 8. And finally, the difference of r and 2, which is r minus 2. We're going to keep going. So, now that we know that a numerical expression contains only numbers and symbols, and an algebraic expression contains numbers, symbols, and a variable, we need to know what in the world is a variable. Well, a variable is simple. A variable just represents an unknown value. So it's something you don't know. Basically, it stands for a number, but you're not sure what that number is right now, so you use a variable. Okay? An example, 4 plus x. Well, we're adding something. Okay, so that's x. We don't know what it is, it's unknown. 10 minus p. Okay, not the yellow stuff. P is a variable, it represents a number, not the yellow stuff in the bathroom. 5y. Remember, that means 5 multiplied by y. Y, we don't know what it is. For example, maybe you get paid $5 for every yard you mow this summer, but you don't know how many yards you're going to mow this summer. So what you could do is later on you could figure out how many and you just plug it in. But right now we're going to say it's 5 times how many every yards. That would tell us how much money. And finally, 20 divided by p. Once again, not the yellow stuff. Do know that 20 over p means division. Okay? Now, a variable can be any letter of the alphabet since it represents an unknown. But I want you guys to get in the habit of not ever using this one. Okay? For example, 6-0. We don't ever want to use 6-0, quite simply because it looks like it's 60. We don't want to use O ever. O is not a good one to use in math because it makes it look like a 0. So don't use O. Anything else is fair game. I kind of like to stay away from X, but you're going to see it a lot, so we're just going to deal with it, only because people get mixed up with multiplication. So in this note, don't use O ever. Okay, it's a bad one to use. Moving on. Now, in order to translate a word phrase into an algebraic expression, we must first know some key word phrases for the basic operations. Now, these seem really easy. However, there's something you need to memorize, and it's going to be really important. And when we get to that, I'll let you know. So for now, let's get moving quickly. In your notes, you have a 4-box section where we have addition, subtraction, multiplication, division. We're going to start with addition phrases. Addition phrases you're going to see when you write algebraic expressions are going to be more than, okay, increase by, greater than, add, total, plus, and sum. And those are the ones that you're going to use. Okay? For an example, here's an addition phrase example. 3 more than x. You want to write this one down. 3 more than x simply means x plus 3 or 3 plus x. The sum of 10 and a number c. And a number n increased by 4.5. Notice that we have a variable, we have numbers, okay, and we're going to have operations in all of these. Those are examples. Okay, subtraction phrases. This is where it gets important. Subtraction phrases. Decreased by. Difference between. Take away. Less. Subtract. Less than. Subtract from. And take away from. And now I need to point this out. This is very, very important. Notice that we have less than, subtract from, and take away from. They all have a star next to them. Please make sure in your notes that star is there. In a few minutes I'm going to tell you what that star means, but I will warn you now, it is very important. This is the part of the video that is difficult. It's the only thing that's difficult. Everything else is super easy with this, but this is what makes every 6th grader make mistakes. So you have to know this very well. We're going to move on, but no, I'm coming back to it. Okay, subtraction phrases, for example. Okay, one of you might want to write down a number t decreased by 4. Okay, the difference between 10 and a number y, and 6 less than a number z. You can write 1 or 2 of those down for your notes, but all of those represent subtraction phrases. Now remember, you need to be able to write the actual expression from a phrase like this. So our job, okay, our job is to be able to take this phrase and say, actually, that is t minus 4. Okay, that's what you need to do. T decreased by is minus, what are we minusing by? 4. That's our goal. That's all we're doing today. Here's some others. When you see the symbol star, okay, so when you see that star, it means that you must change the order of the number and the variable. Okay, you must change the order of the number and the variable. Basically what happens is it flips the order of how you write it down. For example, okay, 5 less than x. Okay, for example, 5 less than x. Here's a perfect example of what we're talking about. Less than is one of those that had a star next to it. Okay, so that's really important. And if I look at this, I have 5 less than means subtract, and x, well, that's our variable. But here's the deal. This one flips it, okay, because you're taking something away from x. So because you're taking away from x, and when you do subtraction, the order matters, you have to get this right. What it does is it actually takes both of these and flips them around. What your actual answer should be is x minus 5, because you're taking 5 away from x, or 5 is less than x. So that's where it's really important. You need to know what that star means. Remember, it simply flips the variable and the number. That's what it does. You flip the variable and the number. Moving on. Multiplication phrases, we're going to go a little bit faster. Product, times, multiply, of, that's a big one, twice, or double. Okay, you might even see triple. I would write that one in there as well. Triple. That one, hey, when I look at your notes, I'm looking for that one for a free point. Triple. Okay, so product, times, multiply, of, twice, or double something. Oh, there's triple right there. Okay, multiplication phrases. The product of 3 and a number t. That just means 3 times t. Twice the number x, that's 2x. And 4.2 times the number e, that's just 4.2e. Okay, and finally, okay, the product of 5 and a number c. Remember, product means multiply. That means it's going to be 5 times c, or we can also write it just next to it, which means multiply, so 5c. Okay, next one, 7 times a number t. 7 times t. Well, what do you think that's going to look like? Probably 7t, or 7 times t. And finally, 6 multiplied by a number d. I think you can figure this one out. You should try it before I do. If you need to pause for a second, do so. Just write it somewhere really quickly. It's very simple. It should be 6 times d, or 6d. All right. All right. Now, there's a placement rule for multiplication. This is a little important. Little placement rule. Okay? You always write the variable after the number. Okay? So always write the variable after the number. That is a very important rule. Okay, you notice that in every single one of these, the variable is after the number. You don't see things like CT, or sorry, not CT, but I apologize, C4. Like, right? That's for bomb making. We don't do that. It doesn't mean C times 4. What you do is you notice that there is always the number first and then the variable. That's important when you write these. All right? All right, division phrases. Here's some more. Quotient, divide, divided by, guess divided by twice. Split equally, that's the last one. Okay, there's just 4 of them. You need to write all 4 of these down. We might add to them later. Our video's getting a little long, so I want to get moving. Division phrases. For example, the quotient of 25 and a number b. The quotient of 25 and a number b. The number y divided by 2. And finally, 2.5 divide g. Ladies and gentlemen, write one of these down as your example. Moving on. Okay, we already talked about the symbol. We're going to get started. This is what our goal was. At the beginning of the video, we said we needed to be able to write algebraic expressions using addition, subtraction, multiplication, and division. Right now, you need to grab worksheet number 1 because worksheet number 1 is two-sided. I'm going to give you the first 7 answers. You need to follow along with me. Pause the video and then come back as soon as you're ready because we're going to get started. Here we go. 3 is subtracted from y. Now, subtracted from, notice I'm going to put a box around the number. Okay, we're going to use what we call the, let's just move on. We're going to box around the number, we're going to box around the variable, and really important, we're going to look at what we're doing. Subtracted from. Well, that means subtract, right? 3 subtract y. But subtracted from has a star. So what does that mean? Well, it means that these two things need to be flipped, which means we should have y minus 3. And that should be your answer. Next one, 7. Oh, we identify the number, we identify the variable, and we identify the operation, which is add. So we have 7 plus h, and that's order. We can keep it right there. 7 plus h is exactly. R minus 4. Okay, that one's pretty easy. If you can't do that one, we have some problems. R minus 4. Okay. X is added to means plus 8, x plus 8. Now, you could write x plus 8 or 8 plus x. Either one of those is okay because the associative property of addition means the order doesn't matter. Does not work with subtraction. Okay? Take away 7 from C. Now, if you look very carefully, it says take away from. Take away from is one of those that has the star next to it. So we're going to have to flip them. So instead of 7 minus c, it's actually c minus 7 because we need to flip them. So c minus 7, we have 2 left. 2 left. 9 less than m. Less than, okay, once again it's subtraction, m, but hey look, this one has a star as well. So what do? We flip it, which is actually m minus 9 to make it correct. M minus 9. Remember, order of operations, you do this wrong, it's going to be wrong. Okay, and finally, z divided by 9. Okay, pretty easy, but you have 2 ways to write it. Z divided by 9, or what's most often you're going to see is z divided by 9, just like that. Ladies and gentlemen, those are your 7. Your job is to finish both of these sides. You're going to turn it in for your first worksheet, and then you're going to move on to worksheet number 2. When you're done with that, we'll move on to a next video. Good luck. Have a wonderful afternoon. This is not what you're doing, but it's there. We'll go back. Hey, by the way, I'm pretty sure it's still 7-7. It's almost the end of the first quarter. Sorry we have such a long video. Goodbye.